We do have a lot of questions. I want to say thank you for everyone who joined us. If you have time to stick around, please do. So the first question for all of our panelists. We see that the economic impact of whitefly-transmitted viruses can vary a lot by region. From your experience, which ones usually have the largest economic impact in the different production areas?
I'm going to respond. I would like the Southeast folks to respond as well. But one of the things we see is it depends largely on the crops that are being grown in those areas. For example, in the West, we are most of the U.S. melon industry, cantaloupe, honeydew, and that type of melon. We have a significant amount of watermelon production also. There's more watermelon production in the Central Valley than in the desert regions. But in both areas, we see viruses that impact melon and or watermelon. So those types of viruses are going to be more significant for growers in that kind of a region. Whereas if you move to, and that would be things like watermelon chlorotic stunt affecting watermelon, CYSTV or CCYV affecting melon. Our isolate of squash vein yellowing virus has not caused vine decline in the West. So although we do have that virus, it hasn't been a concern for watermelon production in the West. But if you move to the East, you're going to see different cropping and different production systems. And as a result, you'll see other viruses that are more significant. Sudeep was talking about cucurbit leaf crumple virus. That's a virus that was first described in the West, but it's never been a problem because melons actually recover very quickly once they become infected. So it's really not an issue. But if you look at squash or pumpkin production in the Southeast, it can be much more serious. I'm sure he'll want to weigh in on that. So it really depends on what crops are being produced, what the dynamic is. The other thing to pay attention to is synergism. This watermelon chlorotic stunt, squash, leaf curl virus synergism that appears to be emerging in the West can change some of those dynamics. So as we look at those sorts of things in different areas, we'll see what happens. But the cropping really makes a difference. What's important?
Yeah, I agree with Dr. Minter. In Georgia, in Southeast, the major impact is on yellow squash or summer squash, where we are seeing mixed infection and more predominantly with leaf crumple virus. So squash is severely impacted compared to other cucurbits that has been grown here. The other thing I noticed here is watermelon. We do not grow, watermelon is not grown in during the fall. Here, the watermelon is mainly grown during the spring, and we have less whitefly population or less whitefly pressure in Georgia during the spring. So watermelon is not impacted by this particular group of viruses. But the grower do not grow any watermelon during the fall crop, and one of the reason is huge whitefly and whitefly transmitted viruses. So squash is the one that is significantly impacted, and as mentioned, cucumber, cantaloupe, those are there, but they are much mild.
Yep, I would just join in from Florida. I mean, Sudeep is right. Fall planted cucurbits get hammered more by whiteflies because they built up all summer. Though Florida is usually a little different because we never get much of a winter, this year being an exception. But it exactly follows what Bill and Sudeep are saying. It depends what you're growing, where you're growing it, and when you're growing it. And so for South Florida, the southern part of the peninsula where a lot of our watermelons are, I mean, we are fighting with Texas and Femi's people every year to see who's going to be first in watermelon production. And Florida and Texas are trading that title back and forth. So for us, SQVYV would be a big thing because if you get it, you lose everything. You've invested all of your input by the time you've lost it, and it's a devastating economic thing for watermelon producers.
Okay, Scott, before you go, kind of tied into that, we did have a question specifically for you. As Florida has two production cycles, are the viruses present in both cycles or just one? And then this would be, I guess, relevant to anybody that has warm enough temperatures for two production cycles.
Yes, so certainly I saw that question roll in, a great question. In a word, yes. So we usually do not get cold here, cold enough to impact the reservoirs or the whiteflies very much. And so we have virus here all the time. We have whiteflies here all the time. And if you plant out a susceptible crop, the whiteflies will find it and they will generally bring the virus with them. Generally, though, I would go back to what I just said, which ties on to Sudeep's. The fall season, usually we have more whiteflies than the spring season because there's usually a break in the crops a little bit. But in South Florida, something's growing year round. So it's hard to get that clean break. Thank you.
I'll add to that we have exactly a similar situation in South Texas. As a matter of fact, our acreage of fall watermelon has reduced drastically. Growers try to avoid planting during fall because it's a losing battle. And it's not just cucurbits, it's also tomato. We used to have a very big industry. It's completely gone now because you just can't get on top of whitefly management, regardless of what you do. So we've done surveys across multiple seasons, and we see very high incidence of these viruses in fall versus spring. So spring seems to be, the sweet spot where growers can actually produce crop, without having to, spray virtually every week.
All right, let's see. Our next question, kind of a couple of big picture questions. With many viruses being observed in the last 10 to 20 years, is this increase due to improvements in detection and sequencing technology, or are other factors contributing to spread? Whoever wants to tackle that one.
Yeah, I'll say it's both. And I'll give an example with Texas. 2001 was when I recruited a graduate student to look into virus prevalence in cucurbit crops. Prior to that, the last statewide survey was done about 30 years previously, and they basically documented mostly EVCWG viruses, and the situation just flipped. When we conducted that survey 30 years later. And what was different this time around is, we weren't just testing for specific, selected viruses. We took a global picture. And so as you have, improved detection technologies with high throughput sequencing, with more generic primers, the chances of, detecting some of these viruses, it becomes higher. It doesn't mean that they are newly introduced. They may just be there undetected because, of course, they may exist in mixed infections. And if you are targeting a particular virus and detect it, you always assume that that's what's causing that particular symptomology. But also there is spread going on. I think it was Bill that mentioned the fact that now we have situations where people produce transplants in California and they ship it to Texas, or from Georgia, they move it around, and you never know what gets spread, and it's not just transplants of cucurbits, but also, some of these ornamental plants that may not necessarily, harbor the virus, but they may harbor whiteflies, that may actually have ingested the virus. So I think it's a combination of all these factors, but I'll allow other people to respond as well.
I agree with Dr. Femi here. As he mentioned, when I started here in 2018, and we started using HTS, and is that first time we detected CCYV. Before that, it was only CYSDV. And as it being a mixed infection, we are able to detect presence of number of viruses using HTS. And that is been one of the factor of using HTS for the preliminary screening and confirming it with number of other tools. So detection techniques has been improved, that may have added to that one. At the same time, in Georgia or in Southeast, the whitefly incidents were very severe since 2017, 2016, and that may have been cause of widespread in this area.
Yeah, I'd say global trade of products and agricultural commodities, of course. I'd also just say weather events. In Florida, where most of our cucurbits are grown on the peninsula, almost every year we're getting a hurricane coming from the east or the west or the south, and oftentimes viruliferative insects come along for a ride.
Yeah, I will chime in on that. I don't get too many hurricanes out here in California, but we certainly have a whitefly situation. The interesting thing is most of the viruses that we detect, we first detect them in the desert production areas. This is Sonoran Desert. This is the production area below sea level, between San Diego and southwestern Arizona. And there are times you'll actually see clouds of whiteflies hovering over the field. Looks like fog in the morning, but it's actually whiteflies. We have that many, and I think I've heard similar situations occur in the southeast sometimes as well now. But if you have that situation, you're going to end up with the ability for something to move in quickly. And so having those tools to detect that has been really valuable to us to be able to sort through what's happening. I think Rebecca mentioned at the very beginning today, we did the math on this, and not all of these are whitefly transmitted viruses, but since 1998, which was the first time we found a whitefly transmitted virus transmitted by the bee biotype in the US, that was cucurbit leaf crumple in Arizona and California. Since then, we've been seeing a new virus every 3.1 years and a new whitefly transmitted virus on average about one every 5 years, 4 to 5 years. And that's just too many. But many of these are coming in through the movement of plant material. There is an increased global movement of plant material, and this is just the nature of international trade. It's going to happen. It's not always people moving something on cucurbits. It could be moving on something else. You could be moving a Bogoma virus on some other plant that you didn't know was there. Maybe it has nymphs and it gets missed by inspection. It makes its way in. So once you move into some of those areas where you have an established vector population, it's going to be very difficult to manage some of these broad host range types of viruses that are there, and having those tools is critical. So the high throughput sequencing has been great. We have a lot of methods. I've developed some. Mathis Puree at Florida has developed some others. There are a number of folks that have produced multiplex methods to quickly monitor for the types of viruses that are relevant to particular production areas. And these are really helpful to us, but we've got to keep constantly changing them and adapting them because we're constantly seeing an influx of new viruses. We found CCYV 4 years after it emerged because it looked like the virus we had. But that being said, we were prepared because we actually had the primers in our lab to be able to detect for that virus. But now we've got so many, we just need to kind of have that arsenal in place, I think, to be prepared.
All right, and kind of a related question. Since most virus diseases exhibit similar symptoms, how do you monitor for the emergence of novel viruses? Is high throughput sequencing being used routinely for this?
Yes, for that, I'm using it routinely, at least once or twice a crop season. I'm trying to monitor any new novel virus. So it's being a part of different students' graduate program or objective. So we keep that in our tools and try to monitor the emerging viruses and how they are spreading from either side, east to west or west to east.
All right. Next question. What makes cucurbit species so susceptible to virus diseases? Is there any genetic reason for their susceptibility?
I don't think cucurbit species are necessarily any more susceptible than something else, but we have an industry that is involved in international trade. We have a huge vector population. These are the issues here. I think the vector population is really the problem. When you have something that's so easily transmitted by a vector that accumulates to high numbers and then can establish in a weed population, it's very hard to manage it. And we've just run into that situation. I don't think it's unique to cucurbits.
All right, let's see. We had a question. Given that whitefly transmitted cucurbit viruses are largely concentrated in the southwestern United States, which landscape level strategies, such as coordinated planting or host-free periods or any other, if any, have proven effective?
Host-free periods have not worked with the bee biotype viruses. They've moved into the weeds so effectively, we've not really been able to break the cycle. To use a totally different crop as an example, lettuce mosaic virus in lettuce has been very well managed with a crop feed period and seed testing because there is a seed transmitted element of that. Most of these viruses are not seed transmitted that we're talking about here, and at least certainly not in the natural environment. And with that the fact that these viruses can establish so well in the weed populations and have a vector population, it's incredibly hard to find a way to break the cycle with a host-free period. So it hasn't really worked that well in the Southwest, but it's because there are so many hosts that the virus is hiding out in. I don't know if anyone's from the other parts of the country want to weigh in.
It's pretty similar in the southeast for slightly different reasons, but because we're generally warm year round, we never get rid of the reservoirs. And so you can get rid of the crop, but you've still got the virus and the whiteflies hiding out there. And as soon as you put in a susceptible crop, you're off to the races again.
And we have a unique situation where I am. We are right by the border with Mexico. And so it's just, there's just influx, continuous influx of, viviparous whiteflies, that come. We never really have a break also. Our winters are very mild. And, those whiteflies are tough. They'll feed on anything. I've seen them on long grasses. So, if you steer them well enough, they hide out somewhere. So it's really difficult to practice off-sweep period. Something that Sudip mentioned in his presentation is something we've been, trying to get growers to consider as well, because cotton is a very good reproductive host for whiteflies, and but they don't really cause any major issue on cotton crop, and so there is no incentive, for cotton growers to manage whiteflies unless the population explodes enough for them to cause honeydew that will stain the cotton boll. So one of the things we've been trying to talk to them about is, look, when you are trying to because when you defoliate cotton around here, oh my goodness, it's like a swarm of whiteflies. So one of the things we've been trying to tell growers to consider is, can they consider, putting some kind of contact insecticide in the mix of the defoliants to knock down the population, not because it will benefit cotton growers necessarily, but something that will, just being very good neighbors. But it's difficult to tell a grower to implement something that doesn't affect their bottom line. So it's been, a conversation that we are still having with them.
A couple of related questions. So, talking about different crops, you mentioned cotton. We had a question, this was directed specifically to Dr. Wintermantel, but I think Dr. Alabi just mentioned this. Do you think certain cropping patterns or rotations unintentionally amplify whitefly movement and the spread of Southwest adaptive viruses? So, cotton, obviously. Is there anything else that may fit in that scenario?
Cotton has been the big player, I think, in large part over the years. Areas that have large cotton populations that build up the Bemisia populations has been it's been a challenge, but even without as much cotton production in the desert areas, we still have large populations of whitefly. So it's not all about one crop. There are other hosts that they can feed on and propagate on. So it's again, it's not all about cotton, but there are patterns. And I think the key to remember is slowing the movement between fields. Femi did a great job of describing this scenario. If you can knock down the whiteflies before you defoliate the cotton or before you plow a field, it'll slow the amount of movement of virus into the next crop or the next field. I mentioned earlier with pseudo yellows, movement from artichoke into strawberry into pumpkin. I mean, the virus can move from one to another. If you can break that cycle, you're better off.
I would like to add in this one wild radish. So if you drive to the interstate and you see all this yellow flower, beautiful flower to the interstate, and these are all wild radish, and they are a good host for both the virus as well as the vector. And they are mainly during the non-crop season, but they are acting that breach. And if we can try to avoid, I know it is going to be a big input for the grower, but if we can avoid that, it may significantly reduce or assist us in managing the disease.
All right, we mentioned wild radish. So we had a question, where should you sample an asymptomatic weed for various viruses? So you mentioned, Dr. Wintermantel, that a lot of the weed hosts were asymptomatic. So does anyone that has done this work, I believe Dr. Bagg, you've also looked at some weed reservoirs. Where do you sample those asymptomatic weeds?
So when we sample for the weeds, we try to look within the field as well as at least 100 to 200 meter away from the last row of the from the periphery of the crop, and we try to collect both symptomatic and asymptomatic and document them properly. And at the end, if you are seeing it, there is no virus in the asymptomatic, at that time you can say. But testing has to be done in both symptomatic and asymptomatic. And we have not done that, how far we can go. That type of study at this point, it is 100 to 200 meter from the periphery of the crop field.
And is there any particular, Dr. Wintermantle, maybe you want to answer that? Is there any particular part of the weed, the leaves, petioles, that maybe virus seems to be concentrated in that you've seen?
With most of the whitefly transmitted viruses, the coronaviruses, it's generally best to test some of the older tissues. If it's a weed, it's going to be very similar to what you're going to. It's just the nature of that virus. Those types of viruses, they will tend to accumulate better in the older leaves, typically. Maybe not across the board, but typically that's what we see. With begomo viruses, those will, like watermelon chloride stunt or cucurbit leaf crumple, they will accumulate more toward the ends of the vines first. I don't know if that's true in leaves, but most of these are phloem limited viruses. They will be in the vascular tissue. It shouldn't matter. If you test leaf tissue, you should be able to find them if there's a fairly substantial titer there. Scott, I know you've done some work with squash vein yellowing virus where you've looked at some more difficult to work with tissues sometimes for that. I don't know if you want to address that at all.
Yep, I would offer the counterpoint to you. What you say is perfect for your viruses. For SQVYV, I'd look at roots, and in watermelons in particular, I'd test crowns. And so in the weeds, we would often go with those areas as well. And what to hedge our bets, we'd probably pool all those tissues into a single sample and then test. Because sometimes the weeds in particular, it will hide out in the roots and just be there without any obvious symptoms.
All right, we have a few more questions. Dr. Alabi, this one was for you. Considering the spread of whiteflies in Florida and Georgia, the absence of squash leaf curl virus is interesting. What are your thoughts and hypotheses?
That's a very good question. Maybe Sudeep should to tell us why he hasn't found squash leaf curl in Georgia. It's quite interesting because on the flip side, also, like Sudeep showed, cucurbit leaf crumple virus has been documented in Texas, but we hardly find it. We'll find maybe one positive sample, typically maybe when we're processing whiteflies. So what I'll say is, I'll say that some viruses are more adapted to certain areas than others, and that could be one of the reasons why it may not necessarily mean there is zero incidence of squash leaf curl, but because of the fact that we have this established virus, the begomo virus, it probably outcompetes any particular indication of squash leaf curl. But the reason why this question is very important is it emphasizes the importance of avoiding introduction of some of these viruses to new areas. So whatever you have, you want to keep it that way as much as possible and manage it. What you don't want is to introduce a new virus into the complex, and then you start having a situation where potential for recombination or pseudo recombination, emergence of new variants to occur. But my simple answer would just be that these are viruses that evolved in those areas. The other thing also I'll mention is that if you look at the potential movement of agricultural trade, transplants and ornamentals, as we've been talking about, we are more likely to get materials from certain areas versus say from Georgia to here, for instance. So a lot of the strains of viruses we have on cucurbits here are very similar to what we have in California. There's a lot of companies that work between those two areas that operate, so it makes a lot of sense. But I would probably say it's nothing to do with the fact that the virus cannot establish if it's introduced. It's just that that's the current situation. It can change at any time. I don't know if Bill or Sudeep or Scott wants to add to that.
Great answer.
Dr. Wintermantle, did you want to talk about transmission efficiency between the different whitefly cryptic species? We did have a question kind of related to what Femi just answered, and we had a question asking why only Bemisia tabaci transmits these viruses or no other whitefly species able to transfer viruses. So we did talk about beet pseudo yellows virus, but I know it starts getting complicated when we talk about Bemisia tabaci.
So there are differences. We did some work on tomato many years ago, looking at two different craniviruses in tomato, much like beet pseudojellow's virus and CYSTV, for example. Very different viruses, same genus, not closely related to each other, but they had very different transmission parameters. One was transmitted exclusively by the greenhouse whitefly. The other was transmitted by 4 different types of whiteflies, 2 Bemisia and 2 Triarodes species. And what we saw was there were very different efficiencies of transmission, different transmission parameters like acquisition time, how long the whitefly has to feed, to acquire, to transmit, how long it stays in the vector, how long it's till it's lost, that kind of thing. These vary. They're specific to the dynamic between the whitefly species and the viruses being transmitted. It's not a one-size-fits-all thing. And I think when you look at nature and you look at whitefly transmitted viruses, one of the things we see over time is as the vector changes, virus populations will change, or as another virus comes in that may be more adapted to transmission by a particular vector that's in the area, it may suppress the frequency that you find the virus that was there before because maybe it doesn't acquire as well. Maybe it's competing within the whitefly for proteins or some other component in the whitefly that the virus has to interact with to be retained in that whitefly for a period of time. There's a lot of intricacies to whitefly transmission. That's not really something we want to get into in depth here, but you can't look at one thing and say this is how long it takes. An example of that would be CCYV transmission by B biotype, Q biotype. They're quite different from one another. B seems to be a much more efficient vector than Q based on the work that's been done in different laboratories.
All right. I think we probably need to get to speed round to answer the last of these questions. Thank you all for hanging in with us. So let's see if we can answer with a quick sentence or two. How often is mild strain cross protection used for disease control of cucurbit viruses?
Not so much for whitefly transmitted viruses, but for some other greenhouse type viruses, we have seen those used.
Okay. Is there any synergistic interaction between the viruses that make the diseases worse and the transmission more efficient? So we did talk about that in the terms of symptom development. Does that synergistic interaction affect transmission efficiency?
I don't know the answer to that yet. These are things we're looking at. Does anyone else want to weigh in?
I'll just say possibly, but I've not seen any published work on that. Yeah.
Okay. How does the order of virus infection and mixed infections impact disease development? For example, an RNA virus followed by a DNA virus or vice versa?
It's a very good question and a challenging experiment to do in control condition. So first thing, the problem happens separating the viruses, and they are so always present in mixed infection. It is very, very challenging for us to do that one. So it will be a good experiment, and I look forward to do sometime in future.
We've done some work on that with CYSDV and CCYV, and the timing matters. It does seem to make a difference which one comes first. There was also some nice work done by James Eng and Bryce Falk with, I believe it was lettuce infectious yellows and lettuce chlorosis virus, which are also 2 craniviruses. And there was an issue where you could, if one virus established first, particularly with regard to vector transmission, the vector wasn't able to acquire the others efficiently. So there are binding issues associated with that and maybe some level of efficiency associated with that.
So with respect to that, what we are observing here is even if we try to separate the DNA and RNA virus, and when we are trying to study that one over period of 3 to 4 weeks, we are seeing that the DNA virus is more prominent and overpower the RNA virus. So cucurbit leaf crumple is always overpowering CCYV or CYSDV.
Let's see, we have another one, which is kind of already addressed. Are any of the viruses presented here that are transmitted by whiteflies also seed transmitted more generally? Are any whitefly transmitted viruses capable of being transmitted through seed? And then we had a specific question asking if, in our opinion, if cucumber green mottle mosaic virus could be whitefly transmitted. So kind of related there. I know Dr. Bag, you addressed this in your presentation very well. If you want to reiterate that.
So in our experiment, when we are using infectious clone for cucurbit leaf crumple virus, we have seen that, and it's already published there in APS journal. So what we are finding it with using agrobacterium mediated infectious clone, cucurbit leaf crumple is seed transmitted. What is happening in the nature that in the field condition, we are still investigating it, and hopefully we will have some answer in near future. At this point, I cannot comment on that one, but what we have seen is only restricted to leaf crumple virus and with infectious clone.
All right, and then any thoughts on if CGMMV could be whitefly transmitted? So we will discuss CGMMV in our third webinar in this series.
CGMMV is a very different type of virus. It's the short answer is no. Tune in next time to learn more about CGMMV.
All right, two more questions. Have any of the panelists seen tomato yellow leaf curl virus symptoms in cucurbits? Can you share if that was detected?
We are monitoring it, and so far we have not seen it.
Last question. Thank you all for joining us. Which of the global cucurbit viruses do you think presents the biggest risk if introduced in the United States? And I'm assuming this is talking about whitefly transmitted viruses since that is the topic for today. So whichever panelist wants to kick that off with their answer.
I think I'm going to qualify that statement by saying sometimes the virus you get isn't the one you expect. An example of that is watermelon chlorotic stunt. We found it. CCYV, when it came in, we had been expecting it. We had primers in my lab anticipating it would show up. With watermelon chlorotic stunt, I was expecting tomato leaf curl nudeli, and instead I got watermelon chlorotic stunt. You never really know. We could end up with squash leaf curl China virus, for example. We don't know.
And we do have a fact sheet on that one
And
on
we
our
do have a
website.
fact sheet. But I guess I would put tomato leaf curl nudeli because of the way it is spread throughout other cucurbit producing areas of the world so quickly. It does have the name tomato in it, but it's a cucurbit virus. It's very severe on cucurbit crops. And so it is one I am concerned about because it does seem to spread quite easily. But again, we don't know what we're going to get next.
Yeah, I would second you on that, Bill. And Oscar, we've been testing for that in Florida cucurbits for the last 5 to 8 years, and fortunately not found it, though we did have a few false positives. But I think what Bill says, it really depends. I mean, you can evaluate these things as to what might come, but what you really need to be doing is like Sudeep and Femi and everybody else, just continuing to survey and watch what's happening and talk to the community, because you'll get something that you're not expecting more often than something you are.
The good thing about what we do here, those of us on this call and the greater virology community, we talk to each other, and we kind of keep an eye out for who's doing what and who has what. And I think that the advantage of that is if somebody gets something, it gets it on everybody's radar, and we start looking a little more aggressively for something like that, even if it wasn't something we're expecting. So that communication is really critical, not just within the U.S. but globally. This is a really critical issue for the global cucurbit community and just ag industry in general.
I will add a little bit. My stakeholder has enough in their plate, so I don't want any new. But I keep monitoring what is present in east on the west, and I don't expect it will come one day or the other. But as long as it is delayed, I am happy.
And this is part of why we have these open discussions so that we can all be aware of what's going on and be on the lookout. And with that, I will put in a plug that we are planning, we as in the Emerging Viruses and Cucurbits Working Group, planning to have an open meeting and discussion at the upcoming Plant Health 2026 in Providence, Rhode Island. So stay tuned for details on that. If you plan to attend that meeting, you are welcome to join us to continue this discussion. So thank you all to our speakers. Thank you all for sticking around with us. The interest is obvious and that you've all hung out with us for 2.5 hours. We really appreciate it and appreciate the questions.